So they'll interview somebody 120 and they'll say, what's your secret? And they'll say, oh, I would start every day, is wake up at the same time, wake up with the sun, have a shot of whiskey. Wait a minute. Where glycine acts to stop inflammation, for something called chloride ions to come into the cell, which keeps the switch from being turned on. It's kind of an electrochemical switch, just like a switch on the wall.
Another way to reduce inflammation that is adjacent to glycine, but maybe not as primary, and that's like omega-6 to 3 balance.
Oh yeah, well, so let's go back to our initial analogy of the cops on the highway, right? Well, how do you stop somebody from shooting a gun?
So Dr. Brind, I know that blood sugar spikes can incite inflammation.
Yes, that too. Yes, because why? Even normal amounts of sugar do tiny little bits of damage to the hemoglobin in your red blood cells.
So the gut is often the seat of, it has a lot of our immune cells in it.
There's no excuse for a good diet. Oh, I'm taking this, so I don't need to take care of that. It's good to...
That all works together.
To be holistic about it,
That everybody seems really interested in right now is reducing inflammation. I'm going to share what I do daily, and then I want you to share what you do. If people had to take 5 steps, what do you got? Hi everyone, we have a favorite on the show today, Dr. Brent. He has a PhD, biochemistry, Yale trained, glycine expert, even though he hates when I say that. And we're going to learn about inflammation. We hear all the time about foods that fight inflammation, and we could exhaust ourselves trying to include them in our diet, or we could not fully understand the primacy of certain foods in the inflammatory process. And so that's what this episode's about. Like, which foods are the most anti-inflammatory? Which pathways do they activate? And how can we make this sustainable? Where do we get the most bang for our buck? So welcome, Dr. Brind. You're a fan favorite, and I'm so appreciative for your time.
Oh, well, it's really kind of you to have me on again. And I certainly appreciate it. Love the opportunity because, as a professor, I'm retired. So now it gives me a chance to talk to people and answer their questions, and which come in rather voluminously, as you know, after these podcasts. And it's all very enriching. That's why I don't like to be called an expert, because once you think you're an expert, that's kind of when you stop learning, because you think you know it all. And that's
so true.
Doesn't make for good science, good teaching, or good nutrition, or good anything.
I know, and that's what I've learned. The more I know I don't know. The bigger, the wider, the broader the questions. And I just want to, if you're new to Dr. Brind, he wrote The Glycine Miracle, a book I found about a year ago, and I read it, devoured it, and realized, oh my gosh, not only is he, heavily trained in the areas that I think could help people most, but he also is a professor. And so the way he breaks it down is really intelligent, really digestible. And I think that's why the podcast we do together always performs so well. So what we're going to start with, though, Dr. Brind, and maybe you can tell people a little bit about yourself and your story, and the kind of like different training that you had that makes you a very credible.
Yeah, well, you said I was Yale trained. I got my bachelor's degree from Yale, and then I went to work after that, working in research. So I've been in research now for 54 years. And all the while I was part-time, getting my PhD. So I got my PhD 10 years after I got my bachelor's degree. I got a master's degree in biology along the way, and a PhD from NYU. And that was in a joint program at the graduate school and the dental school, actually, there at NYU at the time. And I took courses there. I took courses at the medical school. So I ended up with a PhD in what's called basic medical science, with a major in biochemistry and minors in physiology and immunology. Curiously enough, a career largely that's centered in steroids and steroid metabolism, male sex hormones, female sex hormones, and diseases associated with them, like breast cancer. Spent a lot of time doing research in breast cancer, prostate cancer. I ended up in nutritional research and in tracking down the metabolism of methionine. Ended up with glycine, because glycine is key for the one carbon metabolism and the clearance of methionine. And curiously enough, what I finally came upon is that the role of glycine, its most critical role, most obvious role, let's say, is in the regulation of inflammation, which has to do with the regulation of the cells that cause inflammation. which are called macrophages. And what glycine does in terms of inflammation, one of the things it does, as you know, if you read the book, that it actually turns out to be both the alpha and the omega of inflammation. It regulates the first step and the last step. Um, but in any case, how it works
Well,
in
stop for me. I want to back up and give people just a step-by-step guide so everyone can understand this. And my editors even want to make graphics for this because they're so hungry
okay.
to fully understand. So tell us, what is inflammation first? Just when we're talking about inflammation, start there, and then we'll get into the pathways.
Oh, okay. All right. Very good. So inflammation is a natural function of the immune system. It's the immune system's first response system. That is to say, before your immune system can make a very specific response, like making an antibody to a particular bug that you've been immunized against or that you've had the disease, that takes weeks for your body to actually do that, for your immune system to do that. But so what happens if, if all of a sudden some kind of plague comes to town and you've never been immunized? Well, a lot of people might die, but the people who survive, and for most diseases, that's most of the people who survive, it's because of this first response, which is these macrophages can detect the fact that there is a pathogen there of some kind, maybe a bacterium, a fungus, a virus, some telltale chemical signature that's fairly general in nature, but you know it's not something good and it's some bug that's got in. So you better kill it before it kills you, because these things can reproduce very quickly and overcome the body very quickly. So that's your first response. So these macrophages then go into what's called M1 mode. I call the rend mode as opposed to the mend mode. They're the first responders, and first responders they're bimodal, kind of like the first responders out there in society, like the cops. If there's an accident on the freeway, what happens? A cop car will come by and will redirect traffic, will take accident reports, call ambulances, call tow trucks, and all that kind of other stuff until, until the mess is cleaned up. And then they'll go back to their barracks or wherever. But all the while they've been armed, but they never draw those arms and start shooting up the place, because that's only if there are bad actors present. So your immune system is in the same way. Those macrophages can get armed very quickly, and that's when they become M1 macrophages and they start shooting up the place. Not very useful if there's no bug that's come in to harm you, because all that inflammation does by secreting these poisons is it does harm to normal tissue. You don't want to do that. So what's the point of inflammation in the case of injury when there's no infection? There is no point. And yet somehow it always happens. Therefore, we've always come to view it as a normal response. And the natural hypothesis from that must be, well, there must be some usefulness for inflammation when there's a sterile injury, a blunt injury, a sunburn, something like that, because it always happens.
Like with an
Well, it
MMA,
turns out,
for example, someone asked with an MMA fighter, for example, if someone just gets knocked out, and
yeah,
is there any usefulness to the inflammation in that event?
no. Happened to me. Not an MMA fighter, but I had a fall. I was dehydrated, and I had not enough water, and then I had a drink of wine, and then I got up quickly from where I was sitting, and I blacked out for a moment. Bam! My head hit the hard edge of a hardwood table, very hard. And I blacked out, like the old Western movies where the bank robber comes in and clocks the guard on the head, with the butt of his pistol, and he's on the floor while they go in and rob the bank. Well, so this is the kind of thing that happened to me, but, it was an accident. But my daughter was there and, called the ambulance. They got me to the ER because for several seconds, at least, most of a minute, I was probably dazed and confused when I came to on the floor looking up. And so they took me to the hospital, to the ER and all that. And of course, my head hurt a lot. It was right back here to the hospital and all that. And they took care of me. My head was still hurting a lot, but only for about 2 hours. And it took several hours. I was still there. After about 2 hours, my head didn't hurt anymore at all. It was a little tender, but it didn't hurt at all. And then everything was fine. Memory was fine and whatnot, And then they recommended, well, you've had a concussion. a very severe head injury. You ought to have it checked out, followed up by this doctor and that doctor. And I just said, no, thank you. I was out of town. I was at my kid's house at the time in Pennsylvania, and I was living in New York. And nothing ever came of it. I was fine because all the while I had been taking my Sweetamine, which I've been taking for years and years, 8 grams a day. And that happened, let's see, that just happened in April of 2018. So now we're talking about 8 years ago, no sequelae, no dizziness, no residual pain, no nothing. So much for a severe concussion. There was injury, but no infection.
Yeah, so you're saying that inflammation doesn't necessarily come in and speed the healing process. It's not a necessary
It
part.
doesn't speed the healing process at all. It just does damage. And so what most people, when they have a head injury like that, they're gonna feel it afterwards. There's going to be a risk of the traumatic brain injury that becomes chronic encephalopathy and all of that. But this just went away, and it's not the first time. As you know, if you read the book, you know that the first time I had a fall on my tailbone, and from 4 feet onto a concrete floor directly onto my tailbone, and it really hurt a lot for about half a minute. And by that evening, I was dancing. My wife and I had actually tickets to a dinner dance. And the next day, I felt perfectly normal. I only had a big bruise on my lower back to prove that I had had this fall. And then I had a severe sunburn some months after that. That was all in 2010. So due to the self-experimentation with glycine, I had been taking glycine every day since about 2008, about 10 grams a day. This was finally, those instances provided those aha moments that said, wait a minute, something I always expected to happen. Of course you're going to get inflammation. You've had a bad fall. You've had a bad sunburn. It's going to get inflamed. It's going to get painful. You're not going to be able to get dressed, undressed, and bathed without excruciating pain, because I had experience with that over and over again in my youth when I had done this to myself, going to the beach without sunscreen and all of that. Well, it didn't happen. And so I realized, also with research that had been done by some very good people at the University of North Carolina about glycine and inflammation, putting two and two together and realizing that not only was it the glycine that was stopping the inflammation, but rather than viewing it as sort of a drug kind of effect that would therefore prevent a natural reaction from occurring, but to realize that this natural reaction was not a natural reaction. Everybody still thinks, almost everybody, that inflammation is a natural reaction to injury, tissue injury, sunburn, chemical injury, right? Oxidative damage is still damage, still injury. Any kind of normal mechanical function, just blood circulating, especially when you're doing vigorous exercise, you're going to get turbulence in high pressure branch points of your circulatory system. How many times have we heard about the joggers, the people who love to jog and love to, run marathons, and they're in such wonderful shape, and then one day they drop dead right on the track.
Right.
Because whenever you do that, you produce micro injuries. And eventually, it can build up into heart disease and cancer and all. We can talk about that later. But the main thing is inflammation, because this is what at least science understands now is at the heart of it. But the going theory, that what they call the prevailing dogma, is still that, well, inflammation is all normal, and we don't know why sometimes it gets chronic, why it's not self-limiting. We don't understand that. And the thing to understand is, as in many things in science, it's simpler than you imagine. Because you're always thinking scientifically, you don't even realize it, that you have a head full of assumptions about what should happen, what does happen, what's natural, what's normal. Instead of just saying, oh, look, this is an experiment. We don't know what to expect. We're just going to take what we see. And if it's unexpected, so much the better. Unfortunately, in science these days, they say, oh, you stumbled upon something. So some people will say, oh, Brind stumbled upon this hypothesis of glycine and inflammation. And I say, no, you stumble when you're not paying attention. You discover something when you are paying attention. And what we mean when we say stumble is we mean you saw something, you observed something that was not expected.
Nice.
That's when you make a real discovery. Wait a minute.
Yeah.
I was expecting this, but that happened. Instead of saying, they talk about the discovery of penicillin, how Alexander Fleming was not the neatest guy in the world with his mold cultures and his bacterial cultures. And he discovered that his bacteria in some cultures had spots where the bacteria had died.
Yeah.
And he realized that something had dripped from his mold cultures and had gotten into his bacterial cultures and had killed the bacteria. Well, my hypothesis is that there were probably 100 scientists just like Fleming who saw that their bacterial cultures had been contaminated and said, ah, crap, contaminated again. I got to start from square one. Nothing works for me. And never noticed, never made the connection. Wait a minute. That shouldn't happen. I wonder why that happened. I wonder what killed the bacteria.
I
So
love that.
it Pasteur said it best. He said, chance happens to the prepared mind. And
Mm.
prepared means get rid of all the assumptions. Just look at something clean
Ooh.
and then be ready for whatever happens. And if it happens in contrast or in contradiction to what you expected, that's not stumbling, that's discovering.
So, Dr. Brind, you got so much to share on glycine, but can we start first? What happens when we just go in with an NSAID, or we just go in with a steroid, or some sort of biologic, or immune suppressant? Why is that maybe a problematic way to go about?
The reason why these things work is that they're targeting some specific aspect of inflammation or some specific outcome of inflammation, like pain. So if you take an analgesic, and that's also a little bit of a misnomer when they call these non-steroidal anti-inflammatories, NSAIDs. Yes, they're anti-inflammatory, but we don't actually usually take them because they're anti-inflammatory so much as because they're analgesics. They also directly inhibit pain. But this is what a lot of things that come out, they say this fights inflammation, this or that. Especially you see these expensive so-called biologic drugs, the MABs, monoclonal antibodies. Humira is probably the best known and the longest running one of these. And what Humira does, I think it targets what's called TNF alpha, which is one of the higher up mediators on that inflammatory cascade. You inhibit TNF alpha, you inhibit a lot of inflammation, but it's not the first thing, it's down the line. And you're also trying to inhibit a normal function. So you'll notice that in all the ads for all the advertising for these MABs, monoclonal antibodies that are targeting inflammation, they target different products of the inflammatory cascade. And you'll notice at the very end, they have this very fast talking warning that says what? That says, don't go anywhere near where there's been tuberculosis. If you've had tuberculosis, if you're exposed to anybody with this disease or that disease or anything like that. In other words, when you have something which is an immune suppressant, it is actually suppressing a normal function of your immune system. And therefore, you're going to be more vulnerable to things that are real sources of inflammation because, there may be tuberculosis, there may be anthrax, there may be bubonic plague. You go into a place where there's plague or there's anthrax or something like that, or tuberculosis, and you're taking these immune suppressive drugs, you're going to be real vulnerable because if you get exposed, what's your body going to do to fight back? Its own armamentarium has been suppressed. So you can't fight back. So you're going to be much more vulnerable to any of these diseases. Glycine, on the other hand, is what your body actually uses to keep inflammation under control. It's a trigger lock. So inflammation doesn't happen when it's not supposed to.
Well, give us that hierarchy because I think that's really important to lay the foundation for what is this hierarchical response, and because it will teach us exactly why glycine is so important.
Sure. Well, and here's the other thing about glycine. When you talk about glycine and how important it is in the diet, most people who are schooled in the science start talking about the biochemistry. You talk to Dr. Senna, for example, about glycine. It's all about the biochemistry. Hey, Brind is a biochemist. Well, remember, I have a basic medical science, biochemistry, physiology, and immunology. The way glycine works is actually not biochemical in that way. It is a biochemical, sure. It's a chemical. It's incorporated into proteins because it's an amino acid. It does a lot of different things. in terms of biochemical interactions, which means it reacts, it participates in chemical reaction. Pieces of glycine get incorporated into this or that molecule of DNA or some other molecule. That's biochemical transformations, chemical reactions. Where glycine acts to stop inflammation or to regulate inflammation so that it doesn't happen inappropriately is not biochemical. It actually serves as a gatekeeper, which turns the valve. You have enough glycine, the valve is open for something called chloride ions to come into the cell, which keeps the switch from being turned on. It's kind of an electrochemical switch, just like a switch on the wall.
Which releases cytokines, right?
Well, the switch actually starts by just releasing an ion flux. So now calcium ions come in, and the surface of the cell becomes what we call depolarized. See, the polarization means, very simply, when something is polarized, it means it's got a plus end and a minus end, It's like the switch on the wall. When the light switch is off, that switch on the wall has two wires connected to it, right? It has a live wire and a ground wire. So there is a voltage in between the live end and the grounded end, or the unlive end, of 120 volts. That's called an electrical potential. It's a voltage, 120 volts. And the light is off. When you flip the switch on, what are you doing? You're bringing the two poles together, connecting them. So now the voltage between the two poles of the switch is zero, and the light goes on. The electricity is being conducted. So the surface of the cell has a potential also. It's not 120 volts, it's about 70 millivolts. About 0.07 volts is the normal, what we call a resting potential of most cell surfaces. And that's maintained by the fact that there are ions, which are dissolved atoms or molecules that are electrically charged, plus or minus one or more electrons. So, for example, sodium ions have positive charges, potassium ions have positive charges, and chloride ions have negative charges. Now, the resting potential means the potential is such that the cell is charged negative on the inside, positive on the outside. So in the ordinary business of the cell doing its business, there's going to be leakage. So this potential will gradually, naturally deteriorate because chloride ions will leak in, sodium ions will leak in, potassium ions will leak out. And the voltage, because of this leakage, the voltage will tend to deteriorate, especially when a macrophage is not activated, but when it's around doing its M2 mend mode, it's doing phagocytosis, right? Gobbling up, bits of cells and cell debris and whatever else shouldn't be there, like a little army of amoebas. Well, when an amoeba goes around, it moves a lot of cell cytoplasm, moves a lot of membrane around. You're going to get even more leakage of ions. You're going to get more deterioration. So one of the things that maintains this polarity is the glycine gated chloride channel, called a glycine receptor, but it's basically a pipe. It's a tube. It's an opening in the cell membrane that has a gate on it. It can be opened or closed or partially opened. And in order to be fully opened, it needs to have a very high concentration of glycine outside the cell. There are also pumps. For example, sodium ions will be pumped out and potassium ions will be pumped in on an ongoing basis, just as the cell maintains what we call homeostasis, stays the same inside and outside. It's rather like a ship at sea. If you're on some sort of cruiser, out at sea, and you go down into the lowest part of the hull, what do you see? There's going to be a bilge pump. There's a pump always going to do what? To pump out the water, because just from sailing around, some water is going to splash in, and you need to constantly pump it out. If it's never pumped out, eventually the ship will sink because it'll fill up with water. So the same way, these pumps are always going, but one of the key things for the ionic polarization to be maintained is for chloride to leak in through these chloride channels, which are gated by glycine. So glycine, and one of the things that's tricky about that is that biochemically, your body makes enough glycine to do everything it needs to do. Glycine is a very abundant amino acid. There's a lot of it in your bloodstream all the time. There's like what we call level of a normal level is somewhere between 150 and 350 millimolar. That's just the units they use. And that's actually high. Not too many things are in the bloodstream in that high a concentration. And yet, so that's high enough for the body to do everything it needs to do with it biochemically. But it's not high enough to keep those glycine-gated chloride channels open enough to let chloride in. For that, it needs to be at least about 600, between 500 and 1,000 millimolar.
And that's very rare today to have people who have that amount of glycine because
Right.
We're only eating muscle meats. We're not eating more of the other bits like the bones and the connective.
Like the muscle meat has the methionine, which needs to use glycine to get rid of the excess. And so we take lots of excess methionine, and we don't take in the bones, like from bone broth or gelatin, collagen. That's where the glycine is. And yet we tend to throw that in the trash. Your grandma threw it in the soup. I don't care where you come from in the world. Your grandma threw that stuff in the soup. Nobody used to waste food. And in many parts of the world, they still don't waste food. That's an American thing, right?
Yes, it is an American thing. And I just want to stop for a second because this is so important because not only is it like the trigger lock at the top of the cascade of inflammation,
Right.
but it's also a deficiency that we could say almost everyone has today because of the way we're eating, and one that is not recognized, one that people will tell you maybe doesn't exist, right? So I love that. I think this is, your life's work. I mean, one of your major contributions is this kind of discovering, putting these pieces together. Right. Are there other dietary things that can do this, that can act as a trigger lock, or is it primarily glycine?
Well, glycine is the one that's the trigger lock that inhibits or regulates, stops inappropriate inflammation in that way. So, for example, there are a lot of other things. So, for example, so we say injury. If you don't have enough glycine, then the response to injury will be inflammation. Well, how can you stop it? Well, you could stop injury. Because if you don't have enough glycine, but you don't have injury, you're not going to have inflammation.
Yeah. What about
dietary?
dietary?
For example, take all these antioxidants, and probably some of the best known ones would be turmeric, curcumin, the active principle of turmeric, or berberine. That's a big one these days. Very, very good antioxidants. Well, one of the things that triggers inflammation, and everybody knows that, is when you have oxidative damage triggers inflammation if you don't have enough glycine around. So if you take stuff that prevents oxidative damage, well, that's going to work. It will prevent things from getting to that point where the trigger is going to go off, right?
Yeah.
But if you do nothing else except to lock up that trigger so that only an infection will trigger inflammation, then even oxidative damage won't do it. Even COVID won't do it. Even shingles won't do it. So, for example, I like the example of shingles. I had shingles in 2015, and it kind of ruined half my summer or most of my summer because I was sort of, had this feeling of malaise. I didn't really feel like doing too much. But I had this very classical rash on my lower back, unilateral rash. But the thing is, I found the rash because I was just soaping up in the shower. I felt these bumps on my skin with my fingertips, and I thought, I wonder what that is. Took a mirror to it and said, oh, looks like shingles. My neurologist, who was a friend of mine, said, yep, classic shingles. And it was classic in every way except one little itty-bitty thing, no pain. No pain at all. I mean, the rash was tender because it's a rash, but there was no pain. And people described this as a horrible disease with excruciating pain. It's like your skin's on fire. To me, there was nothing there. And I, with selling Sweetamine for all these years, I have a number of customers who had shingles, had the same experience with shingles. Same thing is true with allergic reactions, skin reactions. There are a number of things where the pain and all the discomfort really comes from secondary inflammation. Gout is another thing. So does glycine stop The basic, when I say it's primal, it doesn't mean that it stops the cause of what's ever bothering you. Glycine doesn't cure gout. Glycine doesn't cure shingles. I still got shingles. I have customers still have gout attacks. But the thing that makes these diseases really uncomfortable or really painful is the secondary inflammation that's caused from the initial insult. So even though it's primal to stop inflammation, that doesn't mean it's primal to stop whatever disease process is causing that inflammation secondarily. So I hope this is,
No, that's so good.
understandable.
Yeah, and so I think if we're building a hierarchy, so to speak, of ways we can reduce inflammation with diet, I would say glycine is up there. It's like it's primal, or it's like primary.
Yes, if you do that, then you're not going to have any inappropriate inflammation. But it
Yeah.
doesn't mean you won't have any other kind of disease can happen, but it will, but any disease that provokes inflammation will be less severe.
Yeah, and it
Some
will not.
cases, like,
Yeah, and it
sorry.
won't cut it off. I'm sorry. Go ahead.
Yeah, and it's, in some cases, like with shingles, it will be the difference between something that you'd want to get a vaccine for and something you'd say, nah. It's like, am I going to get a vaccine for the common cold? Why should I? If I get a cold, I get a cold. I don't need to strain my immune system to come up with yet another set of antibodies for some other condition that I might or might not get, because if I get it, it's no big deal.
I love
So
that.
shingles was no big deal, and
I
that's.
love that, Dr. Brind. Okay, and then the reason you reached out to me, and I loved this, was because we talked about another way to reduce inflammation that is adjacent to glycine, but maybe not as primary, and that's like omega 6 to 3 balance.
Oh yeah, well, so let's go back to our initial analogy of the cops on the highway, right?
Yes, tell us how
So
that
what happens
happened.
when that cop comes to the highway because there's a big pileup on the highway, a chain reaction crash. Now you got a 10-car collision, a 20-car collision in a snowstorm, whatever it is, whatever you got. So now you have so the cops show up. Do you see only one police car? Only one state trooper shows up? No. No, you see one, then you see five, then you see six. Sometimes, if it's really bad, you'll see 20 cops show up from jurisdictions that may be miles and miles away, from 20, 30 miles away. It'll be an APB, whatever they call it, an all points bulletin. Everybody's going to show up. You'll see cops from all over the place with their sirens blaring will show up because it's a really bad pileup. Well, how did those other cop cars know to show up? They had radio call. The original cop car called for backup, right? So how does a macrophage, a lonely little macrophage, one of a 50 trillion cells or whatever you have in your body, how does it call for backup so that thousands of them, or even millions of them, show up and start shooting up the place? That's because of signals they send, and the signals they send are called prostaglandins. So prostaglandins are these little, they're not quite hormones because they don't go through the bloodstream. They're what they call local mediators. So when a prostaglandin is secreted, it diffuses some ways out and calls in for backup, from the immediate area and maybe sometimes the not so immediate area if there's a lot of it and so on. Well, so how do these prostaglandins get formed and get sent? There's not little radio antennas there. It doesn't quite work that way, not like that switch on the cell surface. The cell membrane is actually a very sophisticated soap bubble, if you will. That's what the cell membrane is like. And that's what bounds every cell. That separates the inside and the outside of the cell. Well, in those cell membranes, the main constituents of the soap bubble, right? How do you make soap bubbles? Detergent. So how does the cell make soap bubbles, make cell membranes? Detergent. What kind of detergent? They're called phospholipids. Okay, with a little bit of shortening in there. That's what cholesterol is for. Cholesterol is like shortening. Makes it kind of stiffen up. It stiffens up the membrane so it's not so loose and oily and flow around so loosely. But the phospholipids. Well, phospholipids are made of fatty acids and glycerol. And fatty acids, there may be saturated fatty acids or polyunsaturated fatty acids, monounsaturated fatty acids like omega-3 fatty acids like EPA, eicosapentaenoic acid, or DHA, docosahexaenoic acid, with 18 and 20 carbons, respectively. or arachidonic acid, also 20 carbons, but it's a matter of where the double bonds are. And those are proportional to the structure of the fatty acids you eat. Well, the prostaglandins, what they now call prostaglandins, the E and the F series, and they used to call prostaglandins the I series, made from EPA. So some of them you take, there's a set of enzymes that will take one of these fatty acids. It will and it will start a chain of events that takes the fatty acids off some of these phospholipids in the cell membrane and makes it a cyclic compound. It oxygenates it and puts it in a cyclic compound. Cyclic oxygenation, COX. COX-2 inhibitors, COX-1 inhibitors, right? COX is the first enzyme that makes prostaglandins out of these lipids that are in the cell membranes. So that's what a lot of these NSAIDs are. They are COX inhibitors, so that you can't make prostaglandins. Well, prostaglandins made from omega-6 arachidonic acid are pro-inflammatory. They're the ones that say, hey, we got a big accident here, we need backup, send backup from 20 miles out, 30 miles out. We got a lot of ambulances and everything else. So when the alarm goes out far and wide, you have these prostaglandins, which are made from omega-6. The same enzymes will also, that work on arachidonic acid, will also work on EPA. EPA, or they'll work on DHA. And they'll turn those into what they call prostaglandins of the I and the H series. They used to be called that. I think they've changed the nomenclature since I was a young scientist. But it's the point is, whatever they call them these days, it's the same enzymes that will turn EPA, for example, and arachidonic acid into opposite kinds of signals. So if you don't have enough omega-3, if all the fats you take, you say, oh, I don't eat red meat, I don't eat butter fat, I don't, if you believe all of that low fat this and fat free that and no cholesterol, everything else from the ads of the 60s and 70s and so on, now they're changing their tune. But if you believe all that and you eat nothing but, sunflower oil, safflower oil, and all of these, omega-6, largely omega-6, what they call industrial seed oils now. They're getting a lot of very bad press now. They call them industrial oils as if they're not even suitable to eat as foods, because they're pro-inflammatory. Why?
Do you eat seed oils? I gotta know. I haven't ever
Well,
asked.
I don't know what you call seed oils. For example, I think the best oil there is, if you must know, is walnut oil. Now, walnut's a nut, it's a seed. Is that a seed oil? Walnut oil is wonderful. It has the perfect balance of omega-3 and omega-6, I believe.
Which is what?
Which is about 3-to-1 omega-6 to omega-3. You need a lot less omega-3 than you think. It's about around one omega-3 fatty acid to 3 omega-6 fatty acids. And then also saturated ones too.
Now, those are plant-based fatty acids or omega-3s. So do you think, is that going to translate?
Well, you can get them from plant. You can get what ALA, right? Alpha linolenic acid. Alpha linoleic acid is the omega-6. Linolenic acid is the omega-3, not to be confused with gamma linolenic acid, which is omega-6. It's a whole other lecture on fatty acid nomenclature.
But is that eating those walnuts? This is what I think is interesting, is like how do we make sure those omega-3s get into the membrane? Having a walnut, having leafy greens, is that going to translate directly into more EPA into your cell membrane?
Not directly, indirectly, because your body has to do what's called chain elongation. Because linoleic and linolenic are 18, let's see, and linoleic is C16 or 18. Linolenic. This oleic acid is C18 with 1. That's omega-9. Oleic is omega-9. Linoleic is omega-6, and linolenic is omega. So the EPA. So those are 18 carbons long. what the body has to do in order to turn, for example, alpha linolenic acid into EPA is it has to add 2 carbons. To turn it into DHA, it has to add 4 carbons. They're added 2 at a time. Everything's 2 by 2 in fatty acids. The uh, the it's not a direct. It's not directly into the membrane. The membranes will have some linoleic and linolenic acid in them, but in order to make the EPA, so EPA, it doesn't translate directly, but indirectly. If you start with alpha linolenic acid, when that chain is elongated, you're going to get EPA and DHA. If you start with uh, uh, linoleic acid, you're going to get arachidonic acid, right? So that's omega 6. So omega 6 will stay omega 6. Omega 3 will stay omega 3, but the chains will lengthen. It's also better. To get omega 3 directly in, the best thing to do is to have the animal source, to have, for example, DHA, to get the DHA indirectly and the EPA directly, fish oils. So from nice oily fish, northern cold water fish, salmon. I love salmon. You get those fish oils, and I did those for many years before I came onto the glycine thing. So my measure of inflammation was always pretty low. I mean, if you measure something like CRP, which viewers may know is a general measure of inflammation, back in the old day, they used to do what's called a SED rate, erythrocyte sedimentation rate, which was a crude measure of basically C-reactive protein. And my CRP was always very low. They used to say in those days 0 to 15 was normal, but really, if you were anywhere above 1 or 2, you had a lot. Mine was always, 1 or 2 or less. But still, if I had a blunt injury, I got inflammation. That's why I was so surprised when I didn't after I fell onto a concrete floor and got a sunburn. So there's more to inflammation. But it's a good thing, certainly. And it's very beneficial to have, more omega 3s. Now, a couple of other caveats, which I ran into in some discussion groups online about, fish oil and whatnot. And someone pointed to some research and said, "Oh, well, look at these people. They did this work in rats, and the rats that were fed fish oils actually did worse than the rats that were fed omega 6. So that's not all. Well, as I pointed out in answering this comment, I said, rats don't usually eat fish. So when you're doing animal studies, you have to be very cognizant of where the model is applicable and where it isn't. So you get, everybody knows it's saw that footage in New York City, rats eat pizza. They don't eat fish, So they eat anything. They'll eat anything, of course. Anything you give them, they'll eat. They're scavengers. But their constitution, their biochemical and nutritional constitution is not naturally set up for them to be rich in omega 3 consumption. So, for instance, take a squirrel. Squirrels, they're perfectly happy if they eat nothing but acorns all day long. Acorns are all omega 6. So how do squirrels survive? Well, they're not people. They have a different biochemistry. So you can't just say, well, the squirrels like it, so it must be good for me. We did that with a lot of other animals. You pretty soon you'd be starved to death because there's a lot of things other animals eat that are not suitable for us and vice versa. People who are dog lovers, for example, know you can't feed your dog this, and that, which are perfectly good human foods, but not good for animals. So it really has to do, when we're talking about nutrition, we're talking about human nutrition. And wherever animal research has been involved in formulating things and in devising hypotheses and in drawing conclusions about biochemistry, you got to be very careful that we stick to our own species. If you're interested in dogs, you should do research on dogs. If you're interested in people, you got to do research that's in people.
I love that. Now, do you measure your omega-3 index? Is this something? Because what in my mind, and tell me if this is correct, we go glycine's primary, but then also because what kind of inflammation or lack of inflammation or mediators of inflammation are going to come from your cells? That
Well, it's a
base.
megaphone, whether it's magnified or not. So if you have no, if you have lots of glycine, so you're no trouble with inflammation, you would think, but when there is inflammation, it may be exaggerated. So even if you do get, let's say, a cut, an infection, something like that, that naturally gets inflamed, and you're all omega-6 and got very little omega-3, it might be an exaggerated reaction. So there should be a balance. But but if you don't have an infection, you're not going to get inflammation if you have enough glycine around, because as I say, that's the trigger lock. Well, how do you stop somebody from shooting a gun? You put a trigger lock on it, but if the shooter's not there in the first place, you're not going to get the gunshot.
Yeah,
So all of these things, as I said, if you don't have the damage, so if you can have a diet that suppresses oxidative damage or that doesn't do oxidative damage, you're going to get less inflammation even if you're glycine deficient. So all of these things are useful. To talk about the index, you think I'm a biochemist, I've invented blood tests, I do blood tests all the time. But, I've never done that. That's the kind of thing where you can pretty much tell, and every now and then when I get a blood test I'll know, but I haven't done the fatty acid content. I think I can be pretty sure that the fatty acid content in my blood is going to reflect the fatty acid content of what I eat. And I eat some omega-6. I eat a lot of walnuts. I like walnuts, I like cashews, I like, for example, sunflower seeds are omega-6, and I have some of them, and I like pepitos, omega-6s, omega-3s, medium chain, coconut is a good source of, what they call medium chain length fatty acids, 12 and 14. Butter is a short chain fatty acid, that's saturated fatty acid. That's why it's called butyric acid.
yeah.
Butter, butter, butyric acid, short chain, saturated. Then we have, of course, the rare, C15, literally the oddball, the odd number fatty acid that you need very, very little of, but it's such a small amount that most people ignored it until Stephanie Van Watson said, "Hey, wait a minute, this is important." How important? Well, she did her research on dolphins. And, there's a whole industry now about how important it is for people. And I'm not sure it's as important for people as it is for dolphins, but I have always, I put whole milk in my coffee, and I have butter and not margarine, and all of that, because a lot of scientific research tends to be very simplistic. You test one thing at a time and you get a certain result and you say, oh, it's all about that. So right after World War II, the National Institutes of Health set up what's called the Framingham study, which was because returning veterans from World War II, returning soldiers, were dropping dead like flies in their 30s and 40s from heart attacks. So the government wanted to find out what that was all about. So they did a dietary study. They started with about 700 returning soldiers in Framingham, Massachusetts. By the way, this was in 1948. But in any case, so they decided, because they said, oh, that standard meat and potatoes diet is killing these guys. They didn't get all that, in their rations. They lost weight, and over there now they're having all this meat and potatoes. So it's the red meat. It's the red meat. It's the cholesterol. So what did you have? You had this craze of fat-free this and low-fat that and zero cholesterol, and the whole industry of margarine and polyunsaturated fats, and these are good for you and better to avoid heart attacks. This happened for decades based on those early results of the Framingham study. Then later on, what did they say? They said, oh no, it's not the meat. It's diabetes, it's the carbs. It's not the meat, it's the potatoes that's killing everybody. So everybody, they turn around and, due to the Framingham study and other studies on that, they decided it was all carbs, 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 too many carbs. And now Brind comes along and says, no, it's not the meat and it's not the potatoes. It's the glycine. It's the fact that you're cutting the muscle meat off the bone and throwing the bones into the trash instead of the soup. That's a bigger story. Like eat the meat and the potatoes. What I say about potatoes is carbs are energy foods. They're great energy foods. So if you're a hard working, or hard playing, athlete, somebody who burns a lot of calories and does a lot of physical work, go for it. Have lots of carbs and burn it up. But if you're not, it's fine to go eat a bowl of ice cream, and then, later in the afternoon you go out and you play ball. It's not great to have a bowl of ice cream for dessert after lunch and then sit down for a couple hours and watch somebody else play ball. That's
Yes.
not going to burn the calories.
It's not gonna burn the calories, but also, Dr. Brind, I know that blood sugar spikes can incite inflammation at
Yes,
also.
that
So
too. Yes,
how does
because
that work?
why? Because
Yeah.
blood sugar is very reactive. Sugar is fuel. And that's how you get A1C. That's why A1C is a good measure of long-term level of blood sugar because it shows the low level of damage to red blood cells done by sugar. Even normal amounts of sugar do tiny little bits of damage to the hemoglobin in your red blood cells, enough so that it makes a very reliable measure of what the average level of sugar is in your blood because you're measuring literally the damage it's doing to proteins in your blood. So yes, anything that does damage will provoke inflammation when you're glycine deficient. So all of those things will make it worse. So they
Yeah.
all, there's no excuse for a good diet. Oh, I'm taking this, so I don't need to take care of that. It's good
That all works
good
together.
to be holistic about it.
Yeah, and there's two other things in inflammation that I think you can teach me a lot about really quick. And the first is our like baseline level of inflammation. So the gut is often the seat of, it has a lot of our immune cells in it and it
Yeah.
creates a sort of baseline level of inflammation. So what are the kind of dietary modulators we can use to reduce that? I know probably glycine impacts it, but
Well,
what
yeah, but I don't know. I've wonder about thinking that there should be a normal level of inflammation, and
No,
I
I
don't
don't think there should be.
it's
But if there
debatable. Yeah.
is, what are the ways we can obviously identifying food sensitivities, or maybe what you're thinking is glycine's up here, and you might have these insults that not won't result in that inflammation if you have enough glycine, even at the
Yeah,
gut.
I think that well, okay, so let's put it this way. Let's say something like diabetes, diabetes typically involves being overweight. So I was overweight myself. I weighed about 187 pounds up to a few months ago. For a long time, I was, about 20 pounds overweight or so, above my ideal body weight, not above BMI 25, but above BMI 22 or 23, which is nice right in the middle. So I was above that for about 20 years. So what happened was about it was 19 years ago, because I remember now it was 2007 when where I worked and we did blood tests all the time. I ran a clinical lab and a research lab, and we had something called the blood club. We used to draw our blood every week and do a whole metabolic profile. We measured hormones, we measured everything because we had a lab. So we used to draw blood on each other and do our blood every week. So my boss, who was also a physician, came up to me one day and he said, your blood sugar is getting a little high because my fasting glucose came into 129. Well, they call it diabetic if it's above 125. And for a long time, it was about 100, 105, 115, 121, 110, around there, what they call now impaired glucose tolerance, not diabetic, but pre-diabetic. So I was there, and then it started creeping up a little more. It got up to 129, and my boss said to me, I think you really ought to consider taking metformin because you're going into the diabetic range. So I said, I'll just deal with it with diet, whatever. And I kind of forgot about it. However, that was about the time that I came across the glycine connection and started as an experiment taking glycine. Well, what do you know? But for the next 15 years, without changing my weight at all, I stayed in that impaired glucose tolerance range till last year. Last year, I go to my GP, not the same doctor, he's long gone, but I went to my GP. He said, you really ought to take metformin because now your fasting glucose is 127, your A1C is 6.7. You're really in diabetic range, so you really ought to take something for diabetes. I said, well, okay, but in the meantime, I didn't do that right away. I just lost the weight. So I ended up losing about 25 pounds. Guess what? I'm back to 105, slightly elevated, impaired glucose tolerance to normal, high normal glucose. really without anything. And so, in other words, what that did was what I think the glycine did is for about 15 years, it kept me in non-diabetic territory, but I still eventually got there into diabetes. So it delayed that for something like 15 years. And as you know, there have been clinical trials showing that people with diabetes, type 2 diabetes, non-insulin dependent, if they take glycine, the diabetes will go back down into impaired glucose tolerance range. So in that famous experiment in Mexico City in 2008, the Cruz study, placebo-controlled randomized trial, the diabetics went down from a mean A1C of 8.3 to a mean of 6.9. So it's the primal thing in terms of inflammation, but inflammation is not necessarily the only insult or the first insult that precipitates an actual disease state. Okay, but it will, but to the effect that inflammation is a component, it will stop unnecessary inflammation. And that goes a long way toward ameliorating the effects, especially the secondary effects of many diseases, which now, scientists and physicians all say are rooted in chronic inflammation. The only problem with them is they don't realize why, and they still think that inflammation is a natural response to injury. And
Yeah.
that's what I have proved through my own experience. And, in addition to putting together everything in the literature, that's not true.
Yeah.
And it's just a matter of point of view. If you look at the wonderful review published in 1999 by Wheeler, was the first author of this is the Thurman, the Ron Thurman's group at UNC.
Yeah.
Thurman passed away of a heart attack, I think in 2001. So the group was kind of scattered to the four winds. But they did some wonderful work, which led to some publications even into the early 21st century, where they worked out the details, the molecular details of how glycine works, this business of glycine-gated chloride channels and so forth. But what they concluded was, wow, glycine seems to be is such an amazing compound because it seems to be important in resolving so many different disease states. And this seems too good to be true, but more evidence seems to be emerging that shows that this is the case, that glycine is such a wonderful compound for ameliorating this or that or the other disease state or abnormality. In other words, they're still thinking of it like a drug. I took something and wow, it fixed the problem. What a great drug. Can you imagine these days if anybody said, "Oh, if you have somebody who has that horrible disease, scurvy, give them vitamin C. What a great drug." Is vitamin C a drug that's going to cure scurvy? No, it's a nutrient. Scurvy is a deficiency disease. So to one extent or another, not necessarily the whole disease process, but part of what's going on that's causing the pain, the discomfort, and probably the shortening of life in so many of these chronic disease processes is that inflammation component. And that's because we don't have enough glycine. So if we take enough glycine, you really shut off the inflammation component of any of these disease processes. And that
I
goes a
love.
long way toward resolving chronic disease and all manner of condition that shortens lifespan.
Okay.
So it's
And I
kind
want
of
to flip
looking
to.
at it as it's a nutrient. It's an essential nutrient, conditionally essential nutrient, not as the nutritionists and the biochemists still call it, a non-essential uh, nutrient. And that's very unfortunate. If you call something non-essential, who's going to
People
spend any
ignore it.
money to research it? It doesn't matter. It's
Exactly.
non-essential,
Well,
right?
luckily we have you here, and I just want two more questions before you're going to tell us what your like five favorite ways to reduce inflammation with food. But I don't know if you knew about the Justin Sonnenberg study where they gave fiber versus fermented foods. Have you heard about this study?
No. Tell
Okay,
me.
so let me tell you a little bit about it. It's Justin Sonnenberg, and they basically, I think it was like a 16-week trial, and they gave one arm fiber that they like increased over time, and then the others worked up to six servings of fermented foods. And they noticed they kind of hypothesized that fiber would be more impactful in reducing inflammation, but they found that actually the fermented foods reduced 19 inflammatory proteins, and blew it out of the water in terms of fiber versus fermented foods. So how important do you think that is? Like reducing inflammation at that level,
Oh,
compared to
well,
all the other things you do?
well, it's interesting. I don't know much about it, but I can certainly, hypothesize about it and make some educated guesses at the very least. First of all, I wasn't aware that fiber was viewed as an anti-inflammatory food.
Well, I think in that it would feed the types of bacteria that would produce
I
short
see. Oh,
fatty
it's,
acids.
you mean as a prebiotic or a probiotic?
Exactly. Yeah.
Versus what was the other arm of the study given?
Fermented foods.
Fermented. So that's okay. So in other words, one of them would feed the microorganisms of the gut. The other one would actually introduce cultures of the microorganisms to the gut.
Exactly.
So did they have no fermented food? I mean, that's the trouble with these studies is you end up the ones who had fiber had no fermented foods.
I believe they did not. No, and they
Oh
worked
yeah.
up slowly over to 6 servings. So you think that's why?
Yeah, because that's one of the sort of generic problems with doing scientific research. You do sort of one thing at a time. And so, for example, I say, well, okay, that's fine, but I normally, not every day, but I'll have sauerkraut, I'll have sour pickles, I'll have some foods that are fermented. In the summertime, we make our own pickles. We grow cucumbers and we make our own pickles. So that's certainly fermented
We
foods.
do too. Yeah.
And I wouldn't not have fermented foods. Yogurt, I don't eat yogurt now because I found that it was just too much dairy when I had it. My wife eats yogurt. She loves it. It's good probiotic, whatever. So, and I used to have yogurt, or sour cream that has real cultures in it. You can have foods that are pickled but not fermented. That's something everybody knows. You can say, "Oh yeah, I eat pickles. I buy my pickles in a jar. Pickles in a jar. They add vinegar. They don't really ferment them. They just pickle them."
Yeah. Tell them the difference. Like, because so the vinegar is just tell us exactly what's happening in the two scenarios.
Well, when you make pickles, you just they just naturally have cultures because the yeast and other bacteria they naturally grow on the skin. Like if you wonder, say, where do you get it? Because when you make pickles, you wash the pickles off, you put them in, you put salt, you put pickling spice and everything, you just leave them at room temperature for a week. You got pickles. Where the microorganisms come from? Well, they come from the actual fruit. If you take an apple, and a nice red apple, you want to give your apple a teacher, right? You shine it up, you just rub it on your shirt, shine up that apple for why are you shining? What, because you're rubbing off the apple, it looks cloudy on the surface, right? That cloudiness that you see on the surface of a grape or an apple, that's yeast. These are microorganisms that cause fermentation. So that's there. That's part of the package that's there. And when the fruit gets overly ripe, that sort of comes in and ferments the fruit and turns it into alcohol. So they say that about elephants in India, wild elephants. If there's mango trees around and the mangoes, they get ripe, they fall off, they rot on the ground. The elephants eat the rotten mangoes and watch out because they get drunk. And then you don't want drunk elephants rampaging around. But this is known in India, in the jungle parts of India. So, but that's where the probiotic. So you don't really need the probiotic. The fruit itself is the prebiotic. The actual cultures are there. Now, in an experiment such as this, it may be that if they're specifically not taking any fermented foods, that their cultures, the natural cultures in their GI tract, may be dying off because they do have to be renewed. They're not going to die off completely. And you may notice it from things like if you're attuned to your own body, you notice, for example, what your poop smells like, you know. And
Is
this,
that a good indicator of
oh, sure it is, but exactly what it is scientifically, I don't know what the correlation is, but I know from my own body, you say, well, there's something wrong, or this drug that I took. I remember one time, it was Colace, which is a brand name for sodium doxysate, and I remember I had a doctor prescribe it for me for constipation, and it was like, and it introduced this awful industrial smell. It was like, oh my God, it's just not worth it. Well, you know what I found? There are elements of an alkaline diet. If you take bicarbonate, if you keep your diet alkaline, actually that cures constipation. Believe it or
oh,
not.
so
Just
did
all
you
you need is baking
that?
soda.
Yeah. So are you a big baking soda user
I
for
am now, yeah, because as I say, I cured it. Just curious. Because I remember reading the study where they took normal people to see how much baking soda could they tolerate. And they came up with how much people could usually tolerate, and then they wouldn't take any more. And then the reasons for not taking any more was usually soft stools, quote, diarrhea. That's interesting.
Perfect.
In trying it now, it's like, and I did have horrible constipation problems. They're gone now. Baking soda.
How much do you take a day?
Probably somewhere between 5 and 10 grams.
Okay. Okay. Awesome. I didn't even know it was going to go there. So, but they can also just use vinegar to preserve pickles too. And that's not going.
Oh, yeah, we let's get back to that. Yeah, how do you make pickles? If you pickle it, because what happens when you pickle something, when you ferment it, it gets sour. It naturally produces its own acids, acetic acid, which is vinegar and stuff. You don't add it, but a natural pickle, it produces its own because the bacteria, the yeast actually produce the the acids which give it that pickling flavor, the acid flavor, and also break down the carbohydrates, the fibers in the cucumbers, let's say, if it's cucumber pickles, that give you that taste. So it tastes like pickles, but they're sterile. You get those. So here's the way to tell the difference. If you get pickles and they're not in the refrigerator case, they're sterile. The ones that are at room temperature, they're not fermented. They're just pickled.
Yep. Great.
If they're fermented foods, they're going to be in the refrigerator case when you buy them in the store.
Okay.
That's how you know. That's
Yeah.
pretty much how you know.
And the last thing I want to comment before you tell us your protocol, because clearly you're doing so many things. I love how much wisdom you have. So NF kappa
This is
B.
my laboratory, my body is my
But
laboratory.
I
It's the only one
love
I've
it.
got now that I'm retired.
Yes. Well, and I hope that everybody kind of takes a little bit of that from you, from these conversations. But if you hear like turmeric is one of the most
Turmeric,
famous
yes.
anti-inflammatories and NF kappa B inhibition. And then we have polyphenols over here. They're antioxidants. So where do the like olive oil, right? Oleocanthal, oleoperin, these compounds, like where do those fit into the reducing?
Those fit in largely in two ways: antioxidants and signaling. So as antioxidants, all of the polyphenols, if you know any chemistry, I don't know how many people are knowledgeable about the chemistry, and you see what a polyphenol looks like, the chemical structure, it is great at absorbing free oxygen radicals. Free radicals, all reactive oxygen species, they call them, which are very reactive substances which are formed as a natural product of oxidation. You get like byproducts, which are very reactive. And so you need compounds around to absorb this oxidation, because why? It will provoke inflammation if you have oxidative, because it'll cause oxidative damage, and then damage provokes inflammation in the absence of glycine, or in the paucity of glycine. So polyphenols are great for that. Even monophenols like salicylic acid, which is one of my favorite nutrients. Salicylic acid is very,
Where do you
very,
find that?
very, very good for that.
Where do you find it?
Someone said the best source is fruits like kiwi fruit seems to be one of the best sources. Olives, also a good source. Salicylic acid is, but any kinds of fruits, grapes. Grapes a great source of salicylic acid. So wine still a good source of salicylic acid. That's not affected by the process of fermentation. So you still get that in wine or in grape juice. There was what they used to call the French paradox in research was when they did epidemiological studies, they found that people who were high consumers of saturated fats and meats and cheeses and dairy and all of that kind of stuff had higher rates of heart disease, but not French people, because French people drink wine after every meal or with every meal. So they had a high wine consumption, so they would tend to get liver cirrhosis because they drink wine after breakfast, wine after lunch, an aperitif before dinner, after dinner, before bed. If you've ever been to France, it's amazing, that their livers survive as well as they do. But traditionally in France, you get a lot of liver damage, but not a lot of heart disease. And so the research said, oh, it's got to be red wine, not white wine. So you still see a lot of that around where they say red wine is protective is more than white wine. The original study that showed that red wine is better than white wine was a study sponsored by the Bordeaux Wine Producers Association. They make mostly red wine. So, so they say it's the oh, what's that the one from grapes? I forget now. The that tremendous antioxidant from grapes.
The anthocyanins?
No, not anthocyanins. It's something else now. The name escapes me for the, but
Resveratrol?
yes, resveratrol. It always sounds like it's not a chemical. It sounds like something else. Sounds like an additive for your fuel oil, for your lubricator or your car. Get resveratrol, makes your engine run clean. But resveratrol, the reason why resveratrol is you wonder about it is because it's there's very little in grapes. You really have to concentrate it a lot. But that's one thing. One of the things that's good. All of those polyphenols are very good, or the monophenols, but especially salicylic acid. Salicylic acid, by the way, also walnuts have these things in them. So those things act largely because they're antioxidants. If they absorb the oxidative free radicals, they're going to prevent oxidative damage. And if you don't have oxidative damage causing inflammation, even if you don't have enough glycine, you won't get the inflammation, right?
Yep.
So all of these things help. And also, it's not really fully understood. You talk about these other pathways.
Like Peppa B.
I don't know a lot of the details about these other pathways, except they do have to do with some of the signaling of the inflammatory signals and suppressing the inflammatory signals. So you have, as I said, curcumin, which is the active principle of turmeric, particularly good, and also the monophenols like salicylic acid and any of the polyphenols. And of the polyphenols, I think probably the most well-known and probably the most effective would be quercetin.
Yeah.
And quercetin is named from Quercus. Quercus is the oak tree genus. So people talk about, late in life, for example, whenever somebody in a slow news day, they'll want to do a story about people who live to be 100 and something, right? So they'll interview somebody 120 and they'll say, what's your secret? And they'll say, oh, I would start every day, wake up at the same time, wake up with the sun, have a shot of whiskey. Wait a minute. So there's some literature that says something about alcohol, and to me, it is not about alcohol at all. It's about polyphenols like quercetin. So if you wanted to extract the quercetin from oak, what's the best way to do it? Oh, I don't know. How about a 40% alcohol solution to let it sit there for 20 years?
Interesting.
Right? Aged scotch or whiskey sitting in an oaken barrel is going to have a lot of polyphenols, especially quercetin, from the oak. So there are valuable things. And they say alcohol is bad for you. And, on the long run, having too much alcohol obviously is not good. But to the extent that they can find benefits with alcoholic beverages, especially for very old people, it has to do with, I believe, with the polyphenols that are extracted from the oak barrels that these things are aged in. And I often wondered if I ever had a graduate student. Of course, now I'm retired, but it would be wonderful to have a graduate student as a thesis project to compare the levels of quercetin in every brand of premium scotch and bourbon and whiskey that they could find. Imagine all that grant money being legitimately spent on the finest whiskeys of the world.
I mean, if I were a whiskey drinker, I'd be all over that. Are you?
Yeah, that's right. So anyway, but that's a hypothesis. I haven't proven it. Somebody with a high pressure, high performance liquid chromatography system in their lab, and
I know one. Like I said, I know one. Maybe we.
You know one. Yeah, well, just even suggest that to your mentor was a biochemist who had all that equipment. But that would be interesting. Because you buy a nice bottle of whiskey and you only need about 100 microliters. It's about all you would need to find out, to do multiple testing to find out what's in it and how much. And, so those are important. So polyphenols, yes, you should have a lot of polyphenols. You get them from fruits. You get them from things like walnuts, and other oils. See what they do with oils, and you talk about industrial oils, even olive oil. You can say, oh, olive oil. If it's not EVOO, right, extra virgin olive oil, what does that mean? Well, if you buy olive oil that's just plain olive oil and you look up to the light and it's got this clear, absolutely clear golden color to it, what do? They take the olive oil that's pressed from the olives, which is all cloudy and yucky looking, and who'd want to buy that? And what they do is they deodorize the oil industrially. How do they deodorize the oil? They extract all the vitamin E and other tocopherols, things which are slightly water soluble. Oils, it's all in the oil, but a lot of that's suspended in the oil, and they're really more water soluble than oil soluble. They're in between. So you can actually use water solutions to extract things like vitamin E and polyphenols and other things by deodorizing the oil. That's the industrial term for it, deodorizing the oil. Now you have this clean oil, which has now been stripped of some very important nutrients. So that's the importance really of things like EVOO as opposed to just refined olive oil. And the seed oils, it's not so much that they're bad for you, it's that A, we have too much, and B, they are so refined that a lot of the good anti-inflammatory compounds in them have been removed, and then they sell them back to you as vitamin E supplements, of course.
Of course. And then they might sometimes add it, and I don't know. Okay, now my last thing, because this is the kind of content that everybody seems really interested in right now, is reducing inflammation. I'm going to share what I do daily, and then I want you to share what you think, what you do, and what are the biggest, if people had to take 5 steps.
Oh, okay.
Yeah, so first I'm going to tell you.
This is a 5-step program then that we're introducing?
5-step program, and you can add your
Dr.
alcohol.
Smith's 5 steps to ending inflammation. Okay.
That's exactly right. And you can add your type of alcohol at the end if you want. But for me, my primary is glycine. I'm drinking bone broth every day, 2 to 3 times. I'm also doing my omega-6 to 3 balance. I am taking my omega-3 index. I try to eat fish every day or every other day. We also have a great omega supplement. Sometimes I take that every day as well. I also do a fermented food every day, whether that be sauerkraut, a meat stick, and I do, like you said, lots of polyphenols in coffee, in tea, in fruits, in vegetables, and anthocyanins. We also do like purple potatoes. My husband loves the purple potatoes, and also turmeric. So NF-kappa B inhibition, that's like a gene. It kind of modulates inflammatory genes. So I'm often adding turmeric or taking a turmeric supplement. So those are my big, olive oil every day too. Because of my brain, I have ApoE44. I also have extra virgin olive oil daily. So Dr. Brind, it's over to you. What do you got? What are your best
I got
steps?
nothing better than that. Between the two of us, I tell you what, for your 100th birthday, why don't you invite me on? I might still be around too.
I would love to. We have like a weekly chat. But
of course, I'll be about 200 by then, but
You're not that much older than me. Not that much older. But tell me, Dr.
Seriously? Well, I'm 75. I think that's a lot older.
Yeah, I mean, maybe you got me by about 32 years.
Oh,
so
it's a long time. It's a long time. So, I think I'm 75. Maybe it's 175. I'm not sure.
You look good for 175.
Yeah.
You look good for 75.
Yeah, no. So my thing is glycine every day. I do it by taking Sweetamine, which is my own glycine supplement, which also has taurine in it. It also has 800 milligrams of taurine in it, which is also another very good supplement, especially for muscle and heart muscle. And it also will act like glycine. So I take the glycine taurine supplement every day, and then I like to take. I have avocado. Avocado oil is also good. It's a little like olive oil in terms of the omega-3, 6 balance, but it's got more saturated fat than olive oil.
Which
but the omega-3, 6 balance. So I have avocados every day. Some avocado usually every day. I have the bread I don't have too much bread or too much grain, but what I use is like the sprouted grains. Like Dave's Killer Bread has a sprouted grains bread, because when they're sprouted, the biochemistry changes. When the seed starts to grow, it produces lots of different things, and it's more nutritious. It's less acid forming, for example. And then I usually will have Every day I will have a mixture of nuts, not at one time. I'll have a handful of this and a handful of that. I'll have a handful of walnuts and a handful of cashews and a handful of pepitas and sunflower seeds. I'll have pecans. I'll have Brazil nuts. Brazil nuts are great for people who are low methylators. It's a great in-between meal snack because it's high in methionine, which is very unusual for nuts. So in other words, I get a lot of my protein. I still eat meat, fish, and poultry, but instead of having, like a pound or two a day, like for dinner, instead of having an 8 or a 12 ounce or a pound steak or something like that. I don't have steak very often, or if I have pork chops or fish, I'll usually have a 4, 5, 6 ounce portion at the most. That's it. Now, of course, I'm older. My metabolism is slower than most people, I guess, who are younger, like you, but I'm pretty active. I'm always doing something around the house, building something or whatever. So I'm still very active, bike riding, play ball, do all those things. So, so I do have some carbs, but not many. But most of my carbs will be from fruit. I will always have fresh fruit. I have fresh fruit 3 times a day. I start the day with a lemon, a whole thing of lemon juice. That's now how I've taken to taking my sweetamine, is I squeeze the juice of a whole lemon and I'll put in a packet of sweetamine and a little bit of water. So it's like having a concentrated, like a fruit juice, but it's not so sour that you can't drink it. It's just a very strong lemon flavor. So I like it.
Lemonade.
It's well, kind of like lemon juice, like sweetened lemon juice, but it's sweetened with all of that glycine. Yeah, you could try it. Try. So I start my day with that, and then I'll have eggs. Protein is good from eggs. They're not as acid forming, for example, as meat and poultry and that sort of thing. So I just go easy on that stuff. I just have smaller portions of meat, fish, and poultry and get more of my proteins from things like walnuts, because walnuts are like 15% protein.
Yeah, you have a thing with walnuts. Just tell us, why would
Oh,
walnuts be your one food? I love it.
well, I was with this research foundation where I came up with the glycine eventually. That was 2007. But back in the 1980s, we were evaluating some research from a nursing home. The research subjects was from nursing homes where they did cognitive testing on the basis of fatty acid consumption, and they said, well, they gave servings of, I think it was like a 3-to-1 ratio, it was of omega-3 to omega-6, and there they used the purified fats, the purified fatty acids of alpha-linolenic versus alpha-linoleic. And they found that if they had the right ratio and enough of that alpha-linolenic, that the cognitive testing was better after feeding these for a period of time. And I looked at that and I said, well, that's really very interesting. So the next meeting, I went around the conference table and I put a little cup with an eighth of a walnut in it. And they said, what's this? I said, that's how much of this fatty acid mixture they gave these patients. Because a lot of people, they say, well, a supplement is a concentrated form of the nutrient. Well, not really. If the nutrient you're giving is, let's say, an omega-3 fatty acid, and you have the natural oil, like if you say fish oil is what's believed to be a concentrated supplement of omega-3s, right? You eat a nice serving of salmon. When you're done eating, you look down at your plate before you put it in the dishwasher. What do you see on the plate? At least a capsule or two's worth of oil, just from
Yeah.
just from what's left on the plate. And that's a concentrate. Yeah, sure, it's good to lick the plate, and for this kind of nutrient, is it really more concentrated to take a capsule or to actually eat the whole food? So it hardly is really more concentrated to take the capsule. You want fish oil? Well, for some people who can't stand fish, you never get to eat fish. Yes, take a fish oil capsule. But if you can get to eat fish, have fish once or twice a week at least. And oils are slowly metabolized, so it's not like glycine, where you really need it every day because it has a half-life of measured in hours rather than days. But for oils are metabolized much slowly. They cycle through you more slowly. So if you have a nice healthy serving of, let's say, fish, salmons, let's say twice a week, you're getting plenty. as long as so you don't need to take that fish oil capsule every day. These things, everything that you eat has a different cycle time through your body. And these things are published. You call it the biological half-life, which is that time that it takes for the concentration in your body to be cut in half and then in half and then in half, because these things decrease logarithmically.
Yeah. And that's an important question that I want to end on quickly, and you can finish too. But how long do you think it takes to show these results from if you're able to beef up your glycine intake, you use something like sweetamine? Is that days? Should we know?
Oh, that depends how glycine deficient you are and how much inflammation you have. I have had customers who were really in a lot of pain. The one who was, for example, had a severe auto accident many years ago, and it healed completely, but it still produced continuing pain all the time. And it was so severe that he took this sweetamine, and within a couple of hours he felt the difference. Occasionally, I have had those who feel the difference within a couple of hours. If your inflammation is not providing any pain, you don't feel what's going on inside your arteries. You don't feel what's going on necessarily inside your brain in terms of this quiet, subtle inflammation that's progressing without your knowing it. But if you have inflammation such that you can feel it, you will usually feel that go away within 2 or 3 days of taking a supplement of glycine. And then if you stop taking it 2 or 3 days after that, the pain comes back.
Yeah.
That's been my experience, and also most of my customers, I would say, who have related their experiences, that's generally the time frame.
And if you're
So
taking something,
it's measured in hours. Sorry?
no, it's measured in hours for glycine days. But if you
Yeah,
take
hours.
omega-3s, that's like weeks to months to turn over.
I'm not sure. It might be. It's a lot longer. I know that. So
It's a lot longer.
you,
Well, Dr. Brind, this has been so helpful. Let everybody know where they can reach you. Like you said, you have sweetamine, and this is your book, The Glycine Miracle, and we'll hopefully have many more chats. But do you have anything you want to
Yeah, Joel Brind,
end
you have
on
my
and tell
name.
people?
Yeah, if you go on Amazon, you just search either my name or search glycine, you'll find the Glycine Miracle. You can get it from there. If you go to my website, sweetamine.com, you can buy sweetamine. I don't sell books on my website. Then it involves all kinds of sales tax issues. So I only sell food, only glycine in sweetamine. And but it's certainly very accessible. And if you call the customer service number, you get my customer service people, or leave a voicemail or so on if you want to talk to me. They'll put you through to me when I'm available. I like talking to customers. You can email, just hit the contact page. You can email me and I'll get back to you. We'll get back to you. It's we sell a 12-day challenge to try for 12 days, which is usually enough to see if it's going to work for you. Now, when I say, why shouldn't it work for you? It should stop inflammation for everybody. Yeah, well, it does, but a lot of people don't feel their inflammation, and a lot of people may have pain that's not inflammation. Inflammation is not the only thing that causes pain. So to say that glycine is not an analgesic, so sweetamine is not going to necessarily ease your pain or anything like that. But for most people who have aches and pains in a chronic basis, it's inflammation, or inflammation is a major component. If you stop that inflammation by taking sweetamine or another glycine supplement, you will notice the difference within a few days. And so you can buy a 12-day challenge, or even buy a whole month's supply, a box of 30 sweetamine packets, and it's risk-free. If you don't like it for any reason, just say, I don't like it, I want my money back. You get your money back. No harm, no foul, no risk. No risk in taking it either, because it's harmless. It really is harmless. Among all the things you can take, I don't even know if it's possible to do any harm by taking glycine orally, if it's even possible to absorb enough of it to be toxic. There have been very, very, very high levels recorded because of not the nutritional literature, but believe it or not, the urologic surgery literature. There's a surgery that's called a TURP, for benign prostatic hypertrophy, that was perfected 100 years ago. They still do the surgery. It's kind of like a roto-rooter job. Sounds very crude, and it is. But they traditionally irrigate the site with glycine, which means they're like pouring glycine directly into your veins. And so people sometimes get enormously high levels, sometimes 100 times normal levels doesn't do anybody any harm. Even in the most extreme cases, it actually made people go blind for a few hours. Then everything came back and everything was fine. The people weren't even worried about it. And this surgery, this, as crude as it is, this surgery has stood the test of time for over 100 years. Why? Because men tolerate it so well. Why do they tolerate it so well? Well, they're all pumped up full of glycine, so much so that they probably have very high, completely inflammatory inhibition levels of glycine for at least a week. And by the time that wears off, they're healed. So it's the surgery is so well tolerated, but I don't even believe that the people who do it understand the role of glycine in making this possible. But
Yeah.
it's but that's the real evidence of how enormously safe it is.
Yeah.
So I wouldn't worry about any safe. It doesn't do any harm. That's why I've been selling it for 15 years.
Yeah.
And,
And
I haven't had any trouble.
Yeah, and I've been blown away by, and that's why we keep doing these podcasts, because blown away by the comments, the thousands of comments about people who try sweetamine, try using glycine, try drinking bone broth, and see these remarkable changes in pain, in inflammation, in sleep quality. And so, yes, Dr. Brind, thank you. Everybody go out and choose any lever of reducing inflammation dietarily. And if you wanted the biggest bang for your buck, I would say focus on glycine and then focus on, that omega-6 to 3 balance. Those would be my
enough omega. Usually you get enough omega-6. So just by taking more omega-3, that will help generally.
That's
speaking.
what I mean. Yeah. I meant lowering that omega-6 to 3 ratio, and exactly what you're saying.
Right.
More omega-3s. But Dr. Brind, as always, truly a pleasure. I learned so much from you, and I just can't wait till the next one. So thank you very much.
Okay. Same here.